Pleasant day, sir. Myself, Kottapalli Blessy Sterling. Today I am going to give a PowerPoint presentation about Nyquist plots and stability analysis in the subject called control systems. My roll number is 234G180424. I am from second year electronics communication engineering. So this is my second semester continuous alternative assignment 2. So my topic name is Nyquist plots and stability. In the next slide, we are going to discuss about introduction to Nyquist plots. A Nyquist plot, also known as a Nyquist stability plot or Nyquist frequency response plot, is a graphical tool used in control systems to access the stability of a closed loop system by analyzing the open loop frequency response. It plots the real part of the open loop transfer function against its imaginary part as frequency varies from negative infinity to positive infinity. So this Nyquist plot is a graphical tool which is in the subject control systems for closed loop systems. As we know, the control systems have two types of systems, that are open loop system and closed loop system. So this is for accessing the stability of closed loop system. So in the Nyquist plot is defined as the representation of the vector response of a feedback system as a complex graphical plot showing the relationship between feedback and gain. Here the graphical plot will be between the feedback and the gain. Okay, this is the introduction to the Nyquist plots. Now let us know what is about really meant by Nyquist plots. A Nyquist plot is a parametric plot of a frequency response of a linear time invariant system. These plots are particularly required for determining the frequency response of the linear time invariant using control systems to access the stability of the feedback system by analyzing the open loop transfer function. As I already said that. The Nyquist stability criterion is a key concept used in conjunction with Nyquist plots. It determines the stability of a closed loop based on the shape and position of the Nyquist plot of the open loop transfer function in relation to the point -1, 0 in the complex planes. So this is about what is exactly meant by Nyquist plots. Now in the next slide we are going to see about what is meant by stability analysis. So stability analysis is a method used to determine whether a system will remain stable or become unstable over time by examining how small initial disturbances and perturbations affect the system's behavior. Stability analysis is a mathematical technique used to access the behavior of a system when subject to external forces or changes in its parameters. So in the name itself, it tells about the analysis of the stability. So whether the system or is in the stable or an unstable condition by the in a particular time intervals. So if there is an initial disturbances or small disturbances, then it will be unstable. So determining that parameter is known as stability analysis. It is a mathematical technique. So in the next slide we are going to discuss about how to construct a Nyquist plot. Identify the open loop transfer function. First of all, we need to determine the open loop transfer function, that is g of s h of s of the system. So define the Nyquist contour. The Nyquist contour is a path in the S plane that encloses the entire right half plane. So the contour consists of the imaginary axis from plus j infinity to minus j infinity. A semicircle of infinite radius in the right half plane encloses the axis. So in the next slide, and we're going to see the next step of the construction of Nyquist plots. So map the contour to the g of s h of s plane. For each point along the Nyquist contour in the s plane, evaluate the open loop transfer function g of s h of s. Plot the resulting values of g of s h of s in the complex plane, which forms the Nyquist plot. So finally we need to analyze the Nyquist plot. So before, in the 3 steps, we had determine the open loop transfer function, that is g of s h of s, and then we will be determining the s plane, which is at the right half plane. So we need to do the open loop transfer function, that is g of s h of s, for each and every point in the s plane. After that, plot it. After plotting, we need to analyze the Nyquist plot. Encirclements. Determine the number of times the Nyquist plot encircles the point. By that, we gonna determine the Nyquist plots. Now let's see how to construct a stability margin or else a stability analysis. These are the main 6 steps for determining stability analysis. Step 1. Define a 2D cross section. Step 2. Define the failure surface. Step 3. Divide the model into slices. And step 4. Calculate the weight of each slice. Step 5. Calculate the resisting forces acting on each slice. And step 6. Drive the driving forces acting on each slice. This is the 6 steps we need to follow while constructing the stability margins or stability analysis. By this, we came to know how to construct both of them. And now we will see the applications of Nyquist plots and stability analysis. By constructing it, we need some applications. Otherwise, it's a waste of time of constructing Nyquist plots and stability analysis. These are the few applications of both Nyquist plots and stability analysis. Nyquist plots are widely used in designing PID controllers and other control strategies. As we all know, this is about control systems, so Nyquist plots are widely used in PID controllers. They assess tuning parameters to achieve a desired system performance and robustness. Engineers utilize these plots in various industries, including aerospace, automotive, and robotics. And for the stability analysis, application stability analysis assesses how consistently an application performs its core functions, crucial for user experience and business outcomes, and can be measured by factors like crash-free sessions and error-free user interactions. So these are some applications of both Nyquist plots and stability analysis. In the next slide, we are going to discuss about limitations of Nyquist plots and stability analysis. So Nyquist plots assume linear time invariant systems, which may not apply to all practical scenarios. As I already said, that it is for only time invariant systems. So these time invariant systems are not applicable for practical scenarios. They can be complex to interpret for system with the non-minimum phase behavior. Care must be taken when applying the criterion to systems with delays or non-linearities. Stability analysis, while valuable, has limitations, including reliance on simplifying assumptions, potential for overestimation of safety factors, and difficulty in accurately modeling complex failure mechanism. These are the some limitations of both the Nyquist plots and stability analysis. In the next slide, I want to conclude that Nyquist plots are vital tools in control theory for accessing system stability and performance. Mastery of Nyquist plots enhances the ability to design robust control systems. Continual research and applications of these techniques contribute to advancement in engineering and technology. These are the main keywords or main points I want to conclude by this topic called Nyquist plots and stability analysis. So finally, Thank you, sir. Thank you for giving this opportunity to express my PowerPoint presentation about Nyquist plots and stability analysis. Thank you so much.